today's session we are going to see last group elements in period, the P block elements, okay, that is group 18 elements, okay. So group 18 elements already in your lower section onwards you studied. What are the elements present? There are 6 elements present in group 18, okay. So what are they? Helium, neon, argon, krypton, xenon, at last radon, okay, radon, okay. So these are the elements, 6 elements are present, okay. So here the helium, it is the earth atmospheric helium, neon, argon, krypton, xenon, radon. Earlier in our lower section we studied it is a inert gases, okay, because the earth atmosphere it contains approximately only 1% of 1% only present, okay. So these gases 1% only it is present in our earth atmosphere, okay. So and also for the following elements helium, neon, argon, krypton, xenon, radon. So argon is the most abundant element. This is the most abundant element, okay, most abundant element in our atmosphere, okay. And also so these are the elements present in our earth atmosphere, but in the radon it is a radioactive element, radioactive element, radioactive element, okay, right, okay. So all the elements are present in a, it exists in the form of gaseous and also monoatomic, okay. And it's a general electronic configurations, simply I have to write electronic configuration is NS2 NP6, okay. So this is completely filled orbitals because 6 plus 2 8, so to completely filled and to satisfy the octet rule, okay. And general electronic configuration is NS2 NP6 and ionization enthalpy, second one, this is first one, second one ionization enthalpy. So ionization enthalpy, so along the period and down the group, so compared to other groups of elements, it's the group 18th elements ionization enthalpy is very high. So anyhow, so along the period, the ionization enthalpy very high, especially for helium, its ionization enthalpy, so it is 2372 kilojoule per mole, okay, per mole. So down the group, as usual, the ionization enthalpy completely decreases, okay, down the group it decreases. So why it is decreases? Because of there is no and the size also increases, okay, right. This is ionization enthalpy. And atomic, and third character is atomic ionic radii. So what's happened? So down the group atomic and ionic radii it is increases, okay, because the size, number of shells increases, so atomic and ionic radii also increases down the group, okay. So down the group atomic and ionic radii increases. And so electron gain enthalpy, fourth one is electron gain enthalpy. So electron gain enthalpy here, so one thing, it is a completely filled orbitals, okay, NS2 NP6 except helium. Helium is the only NS2 electronic configuration, okay. So for electron gain enthalpy, it is a completely filled electronic configuration, so there is no tendency to accept the electrons, okay. So therefore large positive values of electron gain enthalpy, large positive values for values for electron gain enthalpy, okay, because of no tendency to accept, okay, right. So these are the periodic trends, okay. What is properties? Second one, properties. So properties, we very well know that this is a colorless gas, okay, colorless. One thing, colorless, as well as all the group 18th gases on the group 18th elements are monoatomic form, okay. This is very very important, monoatomic form, okay, and colorless and tasteless and sparingly soluble with water, sparingly soluble with water, H2O, okay. And so the one question, group 18th elements are low boiling point, melting and boiling points. Why? What is the reason? Because so it is the monoatomic nature. So interatomic forces, so it create the weak dispersion forces or weak van der Waals force of attractions, okay. So ஏன் வந்து இது வந்து low boiling point melting point இருக்கு அப்படின்னு சொன்னோம்னா, the same atomic, for helium means helium and neon means neon. So they have very low melting point and boiling points because only type of interatomic interactions in these elements is weak dispersion forces, okay. So this weak dispersion forces, it is a because of it is a low boiling point and melting point, okay. So low boiling point as well as melting point, okay. So you have to write these points, okay. The same atomic interatomic forces as well as to create the weak dispersive forces or weak van der Waals force of attractions, okay. So that is the properties, okay. And so the, for example, for this here, the helium is a very lowest melting point. Helium is a very lowest melting point. Its a melting point range is 4.2 Kelvin, very low melting point, okay, right. And so next one is that is chemical properties. Third one is chemical properties, okay. Third one is chemical properties, okay. So we very well know that that is a inert gas, okay. This is a inert atmosphere because so these elements, it does not react with any other elements, okay. But many scientists, they tried their they observed their reactivity, chemical reactivity for this group elements, okay. So but it was failed thing because எல்லாருமே இதை வந்து என்ன செய்றாங்க, இனட்டா இருக்கு, எப்படியாவது இது வந்து நியூ அரைவல் கொண்டு வரணும் அப்படிங்கிறதுக்காண்டி ட்ரை பண்ணுறாங்க. பட் எல்லாமே வந்து என்னது, ஃபெயிலியர். ஸோ பட் ஒன் ஸ்டேஜ், ஒன் ஆஃப் த சயின்டிஸ்ட் in the year 1962, so his name that is Neil Bartlett. So he found or he prepared one red color compound, okay. So that red color compound, how he was preparing, oxygen O2 gas react with platinum hexafluoride, okay. So this platinum hexafluoride react with this oxygen to form oxy platinum hexafluoride, okay. So oxyplatinum hexafluoride, okay. So he found that it's in the oxygen, the first ionization enthalpy he noticed that is a 1175 kilojoule per mole, okay. At the same time he observed the xenon, it's a at the enthalpy change, the enthalpy of xenon compound, he found that or else he observed its values 1170 kilojoule per mole, okay. So instead of that he realized, so instead of that oxygen he used xenon compound to prepare xenon platinum hexafluoride, okay. So because of the same energy needed for the compound. இதே சேம் எனர்ஜி தான் நீடட். எதுக்கு அப்படின்னோன்னா இதோட என்தால்பியும் சேமாக இருக்கிறதுனால இவர் என்ன பண்ணுறாரு, இந்த ஆக்சிஜனுக்கு வந்து ஆக்சிஜனுக்கு பதிலாக xenon காம்பவுண்டை போடுறாரு. ஸோ xenon ப்ளஸ் platinum hexafluoride, he invented the first new xenon hexafluoride inert compound. Okay, platinum hexafluoride. Okay, right. This is after that he found many xenon compounds. Okay, xenon difluoride, xenon hexafluoride, xenon hexafluoride, tetrafluoride, like that. Okay, so students, you keep it in your mind. Many scientists they tried, நிறைய பேர் வந்து ட்ரை பண்ணாங்க, ஆனால் எல்லாரோட இதுவும் ஃபெயிலியர் ஆயிட்டு. பட் Neil Bartlett, he is the one of the scientists. He found the new xenon compound. Okay, so new inert gas compound. Okay, so first அவர் என்ன பண்ணுறாரு அப்படின்னா, ஆக்சிஜனை வச்சு என்ன செய்கிறாரு, ஒரு ஆக்சி ஹெக்ஸா பிளாட்டினேட் காம்பவுண்ட் வந்து ப்ரிப்பேர் பண்ணுறாரு. அப்போ ஆக்சிஜனோட என்தால்பி ஆஃப் அயனைசேஷன் என்தால்பி வந்து 1175. அதே இது அவர் வந்து அன்ஃபார்ச்சுனேட்லி ஹீ ஃபவுண்ட் xenonோட என்தால்பி சேஞ்சும் அதுக்கு ரிலேட்டடாக இருக்கிறதுனால அவர் என்ன சொல்கிறாரு அப்படின்னா, இன்ஸ்டெட் ஆஃப் திஸ் ஆக்சிஜன் he used this xenon compound. So after he got the xenon hexafluoride, platinate hexafluoride compound. Okay, so இப்படி தான் வந்து என்னது ஃபஸ்ட்டு வந்து என்னது inert compounds வந்து inert gas compound ப்ரிப்பேர் பண்ணாங்க. Okay, right. So after that the krypton. So all the inert gases react with only for fluorine, because fluorine is the highly electronegative element. Okay, krypton KrF2. Okay, and also RnF2, but it is isolated, not synthesized. Okay, so after that he prepared the fourth one, preparation of xenon compounds. Okay, how xenon compounds are prepared. Okay, the first one, xenon react with fluorine. Okay, now xenon is excess form. Okay, at the experimental conditions the temperature range is 673 and 1 bar pressure. Okay, that is XeF2. Okay, that the binary fluorides are formed. Then the same xenon react with fluoride. This is xenon now 1:5 ratio. At the experimental the conditions 873 Kelvin and 7 bar pressure. Okay, so what's the compound? Xenon hexafluoride. Okay, so this is all solid form. So earlier it is a gaseous form. Okay, gaseous form. Okay, and xenon react with F2. The range is 573 Kelvin and 60 to 70 bar pressure. Okay, now the xenon, the ratio is 1:20 ratio. Okay, so he got xenon hexafluoride solid. Okay, so this is the preparation of xenon compounds. Okay, so the experimental, the temperature and bar pressure, very important, you have to write. Okay, right. Fluoride prepared this method also. For xenon, tetrafluoride react with dioxydifluoride to form xenon hexafluoride and oxygen. Okay, the reactions takes place in 143 Kelvin. Okay, so here the oxyfluoride acts as a good fluorinating agent. Okay, this is one question, one more question. Okay, so for each and every line you must be go through. Okay, and structures. For xenon fluoride, xenon difluoride, what is the structure? Linear structure. Okay, here 2 bond pairs and 3 lone pairs. Okay, this is linear form. And xenon tetrafluoride, it is a square planar, 4 bond pair. This xenon connected with the 4 atom of fluorine and 2 lone pairs. Okay, so 4 bond pairs. Suppose I ask you to draw the XeF4 structure, immediately you must draw this structure and write 4 bond pairs and 2 lone pairs. The structure, the shape is square planar. Okay, so like that you have to do that. Okay, right. And XeF6 distorted octahedral. Here it is a octahedral structure because the xenon bonded with fluorine, 6 fluorine atoms and 1 lone pair is present. Why we have to use here the distorted? Because the lone pair bond pair, the repulsion is more. So this fluorine atom slightly bent, it looks bent like structure. Okay, இங்க இருக்கிறதுனால இது கொஞ்சம் bend ஆயிருக்கு, அதனால distorted octahedral. Okay, so lone pair bond pair repulsion is more compared to bond pair. Okay, so this is a reason. Okay, and xenon fluoride react with fluoride ion acceptors to form cationic species and fluoride ion donor to form fluoroanion, anionic species. Okay, so this xenon fluoride react with both metal fluoride as well as metal fluoride as well as non-metal fluoride. In case non-metal fluoride, the fluoride ion, it is accept the pair of electrons to form cationic species. Okay, so accept to form phosphorus hexafluoride anion and this is XeF plus cationic species. Okay, and also XeF4 xenon tetrafluoride plus antimony pentafluoride. Okay, that is accept the pair of electrons to create the cationic species. Okay, suppose this xenon fluoride react with metal fluoride, what's happening here? It is a fluoride ion donor. Okay, so it created the anionic species XeF. Fluoride ion donor means this XeF7 and the metal cation. Okay, so in the metal it would be a sodium, potassium, rubidium or cesium. Okay, so this is one more question. In case non-metals, it is a cationic species. In case metal fluoride to form a anionic species. Okay, after that hydrolysis of xenon difluoride gives the mild hydrolyzation reactions takes place. Okay, xenon difluoride react with water to form xenon and hydrofluoric acid and oxygen gas. Okay, and xenon oxygen compounds. What are the xenon oxygen compounds there? Xenon trioxide. Okay, and xenon difluoride and xenon oxy difluoride. So many xenon oxygen compounds there. Okay, first of all, hydrolysis of xenon hexafluoride and xenon tetrafluoride and xenon hexafluoride with water to produce xenon trioxide. Okay, so excess of water, hexafluoride with excess of water, it produced xenon trioxide and hydrofluoric acid and oxygen. Okay, at the same time xenon hexafluoride with 3H2O, that is mild hydrolyzation reactions, xenon trioxide and HF, hydrofluoric acid. Okay, so students, you keep it in your mind. Sometimes balancing the equations, கண்டிப்பா இது ஒரு question வரும். இங்க வந்து ஹெக்ஸாஃப்ளூரைடா ஹெக்ஸாஃப்ளூரைடா டெட்ராஃப்ளூரைடா அப்படின்னு பார்க்கணும். டெட்ராஃப்ளூரைடு அப்படின்னா நமக்கு 3 காம்பவுண்ட்ஸ் கிடைக்கும் பாரு. xenon கிடைக்கி, xenon trioxide கிடைக்கி, ஹைட்ரோஃப்ளூரிக் ஆசிட், ஆக்சிஜன் ஆல்சோ. இதே இது ஹெக்ஸாஃப்ளூரைடு வித் மைல்டு ஹைட்ரலைசேஷன் ரியாக்ஷன்னா xenon trioxide and hydrofluoric acid alone. Okay, and this structure, it is a 3 bond pairs and 1 lone pair. It is a pyramidal shaped structure, colorless, solid and highly explosive. Okay, oxyfluorides of xenon. Okay, so how the oxyfluorides of fluorides can be prepared? Okay, partial hydrolysis of the xenon hexafluoride gives oxyfluorides like xenon oxy tetrafluoride and xenon dioxy difluoride. Okay, so these are the compounds. Okay, hexafluoride, it undergoes hydrolyzation reactions to give these two products. Okay, so here XeF6, xenon hexafluoride react with water to produce xenon oxy tetrafluoride plus hydrofluoric acid. Okay, and xenon F6, same xenon hexafluoride react with water, 2 moles of water to produce xenon dioxide difluoride plus hydrofluoric acid. Okay, so completely following types or balance the equations. Usually this type of questions will give and ask you to write balance the equation. Okay, right. And this is the structure for XeOF4. Okay, it is a 4 bond, 1 2 3 4 5 bond pairs and 1 lone pairs. Okay, it looks square pyramidal shape. It is a colorless as well as volatile liquid form. Okay, right. This is for 1 mark questions. Okay. Next, I left one topic that is interhalogen compounds in halogen family. Okay, so what do you mean interhalogens compound? Interhalogen means two halogens combined to give a interhalogen compounds. Okay, so halogen combined among themselves to form a number of compounds, that is called interhalogen compounds. It is a XX dash and XX dash 3, that is a triform and pentaform and interhalogen like hepta. Okay, so here how the interhalogens compound produced, because here X means larger size of halogen and X dash it represent it is a small size of halogen. Okay, smaller size of halogen, which means that is a highly electronegative element, and larger size halogen, which means that is a weak electronegative element. Okay, here two polar, okay, positive and negative like that. Okay, so that X is a more electropositive than X dash. Okay, these are all 1 mark questions, you keep it in that. Cl2 plus F2 gives 2ClF. For equimolar, here you see that for X is a larger size halogen and X dash should be a, it is a smaller size halogen. Okay, it is a highly negative, it is a highly positive like, so polar bond. Okay, so it gives a colorless gas of chlorofluoride. Okay, same thing, excess of fluorine, chlorine with fluorine, excess of fluorine, 2ClF3. Okay, X bond, yes, sorry, X dash 3 type compound we can get. Okay, right. The same thing, iodine is a larger size and chlorine is a smaller one. Okay, highly electronegative and highly electropositive like. Okay, so 2ICl, this is for iodochloride. Okay, and it is a equimolar, least one. It's the excess of chlorine means that is a iodine, Cl3 means XX dash 3 type compound. Okay, this is orange color solid. Okay, so what do you mean interhalogen? Two halogens interact or combined to produce a interhalogen compounds. Okay, here one question, one board question. Interhalogen compounds are more reactive than halogens except fluorine. Fluorine already we studied, because of it undergoes inter-electronic repulsions. Each and every key point you should learn. Okay, inter-electronic repulsions takes place, so this bond is a weaker bond. Okay, here, so that it represent except fluorine. Okay, why, what is the reason? Because here the X dash bond in interhalogens is weaker than XS bond. Okay, in halogen except fluorine bond. Okay, it is a weaker bond because it is a polar bond, highly positive, highly electron. Suppose this weaker bond easily it can be break up and ready to undergo and react with other elements. Okay, so it gives a product, so that the XX dash bond in interhalogens are weaker, so it is a highly reactive compared to iron. Okay, so இங்கே கொடுக்கலாம் உனக்கு, why ICl bond is highly reactive than I2 அப்படின்னு கேட்கலாம் உனக்கு. Okay, this is a question. Okay, and so that it is that's why it is a stronger oxidizing, interhalogens are a stronger oxidizing agent than halogens except fluorine. Okay, So this and all you keep it in your mind. Okay. Another one question, book back question. Why do noble gases have comparatively large atomic sizes? So the key points you should write: repulsive force greater than attractive force between proton and electron. So here you see that helium, what is that? 1s2. Okay, so completely filled. Okay, there is no gain or loss. Okay, completely filled. And also neon means what? 1s2, 2s2, 2p6. Okay, 10, completely filled. Okay, so that the here the nucleus shells. Okay, so here the attractive force is very less, proton and electron, because completely filled. Okay, so that use these key points. Repulsive force is greater than attractive force, so it looks comparatively larger atomic radii. Okay, and another one question, why it is a inert? In the group 18 the elements are inert in nature. Use these three key points. The first one, completely filled orbitals, and the second one, that is a higher ionization enthalpy, and there is no tendency to gain. Okay, so larger positive electron enthalpy. Okay, value of electron enthalpy, gain enthalpy. Okay, so these are the key points you should write and get your marks. Okay, after that, at last, uses noble gases. Helium, it is a inflammable light gas, and it is used for filling balloons and meteorological observations, and it is used in cooled nuclear reactors. Nuclear reactor cool பண்றதுக்கு இது இந்த helium gas வந்து யூஸ் பண்றாங்க. Okay, பவர் ஸ்டேஷன்ஸில், அட்டாமிக் பவர் ஸ்டேஷன்ஸில். அண்டு ஒய் இஸ் ஹீலியம் யூஸ்ட் இன் டைவிங் அப்பேரட்டஸ்? ஏன் இதை யூஸ் பண்ணுறாங்க அப்படின்னோன்னா, ஹீலியம் இஸ் யூஸ்ட் அஸ் அ டைல்யூயன்ட் ஃபார் ஆக்சிஜன் இன் மாடர்ன் டிவைசஸ். ஸோ இட் இஸ் அ வெரி லோ சல்யூபிலிட்டி இன் பிளட். பிளட்டில் வந்து ஃபாஸ்ட்டாக வந்து சல்யூபிள் ஆகாமல் அதாவது லெஸ் ஒன்லி இட் இஸ் சல்யூபிள், ஸோ தட் இட் இஸ் mixed with oxygen. Okay, and the oxygen cylinder la ideyum mix பண்றாங்க because of low solubility. Okay, right. And neon, it is used in discharge tubes. Discharge tubes already you studied in the ray optics chapter எல்லாம் படிச்சிருப்பீங்க. நிறைய அந்த கலர்ஃபுல்லாக அப்படியே வச்சுருப்பாங்கல்ல அந்த ஷாப்ஸ் எல்லாத்துலேயுமே. ஸோ தட் இஸ் அ டிஸ்சார்ஜ் டியூப்ஸ் அண்ட் ஃப்ளூரசன்ட் பல்ப்ஸ் அண்ட் அட்வர்டைசிங் பர்பஸ். ஓகே, அண்ட் பொட்டானிக்கல் கார்டன் அந்த அட்மாஸ்பியர் in green gases. Okay, organ used mainly to provide inert atmosphere in high temperature metallurgical process and filling electric bulbs, and used in laboratory. Xenon used in light bulbs and designed for special purposes. Okay, so that's all. I hope I covered all the in-text questions as well as the book back questions, and also extra questions also we covered. Okay, that's all children, this lesson over.